happens during the glycolysis. We're going to talk after the spring break. Then become 1,3-biphosphogycerate, then become pyruvate. We'll talk about chemical name, but not structure, okay? You go here, see? This is a very important picture showed you here. First of all, glycolysis and the fermentation are coupled if the bacteria need to survive. Second, there is a free available NAD is recycled. So it tells you two things. That's a very magically important picture. Lots of people don't understand what the NAD goes. That's an electron carrier, it's recycled. It's most key. We get to the bottom where the bacteria can survive. And this is the same thing, the reason why bacteria only have 2 ATPs during fermentation. Regardless of hetero or homo, they can survive because of that. This is you like. What's a fermentation wheel comes out? Did you ever eat Swiss cheese? Very acid. Because probionic acid. Probionic acid is not come out naturally. It's from a bacteria called the probionic bacteria. Here is something, a knowledge we need to let you know. You learned these in your chemistry class, is that right? They're called fatty acids. We have a very short chain fatty acids in this guy. Formic acids. We have a next one very short chain fatty acids, acidic acids. If we go this guy, that's propionic acid. Coming from probionic bacteria. So you see the Swiss cheese, how did the hose come in? It's a gas, carbon dioxide. Because fermentation will create the carbon dioxide. That's the first way, the application. Second, we do every day. You like cheese, yogurt, soy sauce, what they do? That's aspergillus, lactobacillus, streptococcus. That streptococcus is not a pathogen. It's a beneficial bacteria. So I told the people all the time, do not look at the genus name to make the decision. This looks like you don't look at the people's face, say that you're good or bad. Don't look at the streptococcus, think we talk the whole section, said they are really bad pathogen. Here is a beneficial bacteria. That streptococcus semophiles, they even resist a little bit of heat. They will be doing fermentation, create lactic acid. This everybody likes. Saccharomyces will generate ethanol, beer and wine. And also we have a carbon dioxide that comes out. Now for the beer, we have ale and lager, is that right? The ale usually looks like light, the lager is dark, because that's a top and the bottom fermentation. Now, when we make a beer, what do we use? We use malts. And we have to soak the malts. Why? Because the malts is usually rich in a starch. When we break down starch, what we need amylase. But usually the malts, they don't have amylase, so what we do? We soak it. Okay? So that's, and the pathogen can do the fermentation is Saccharomyces. Saccharomyces cerevisiae, that's a very good one for the fermentation. Nail polish remover. You can get the bottle from Sephora or Ulta or those stores. It's quite expensive. A small bottle is $10, $20 could be. Now where they come from? You'd never believe it. We talk about the Clostridium, the whole section, it's really bad, but Clostridium could be good. Going through fermentation, generate acetone and isopropanol. It's a nail polish remover. And going through the fermentation. Last one. Vinegar. We just said, vinegar simply can do is you open a bottle of wine or you loosen the cap of a bottle. You put at the room temperature for a month or 2 months. Then you taste it, it become acid. Secondary fermentation become a vinegar. But if you want to do it really quick, you could use E. coli and Acidobacter to generate acidic bacteria. Acetic acid. Acidobacter, look at this. The genome name already tell you it will generate acetic acid. That's a vinegar bacteria. That's E. coli. Is what I mentioned in the first class. That's E. coli 9037. It's not the E. coli 0157H7. It's 9037. It's the same genome name, but it's a beneficial bacteria to generate the vinegar. So it's very interesting when we talk about the application of the fermentation. There are lots of the information out there. It's all the beneficial bacteria all of a sudden, although looks like they are passive. Okay. Aerobic respiration. We already been drawing you the blue plan here. So we have a glucose going through a glycolysis process, generate pyruvate. Have the transition step, generate the silyl-CoA, and going through the cycle called the citric acid cycle. And what's the way we do? We want to generate ATP. This is the way we usually say central metabolic pathway. Which we are talking about right in the middle. Fermentation, you can understand, it's a really special. Epidemiological pathway is glycolysis. We'll talk about after the break. But let's talk about one thing. A very simple question to you. Then we are off today. We talk about energy currency. That's ATP. Do you ever know the structure of ATP? I like chemistry. Maybe you don't like it, I like chemistry. What is the structure of ATP? It's very unique and very interesting we talk about. Is that right? If you don't know, let's just write A. H, OH, H, CH2, goes here. Goes here. That's ATP. Then what is A looks like? Well, let's just do a little bit complicated. Is that right? That's ATP. Adenine, triplet phosphate, ribosome. That's ATP then. What we talk about. This is 5'. So what's the phoneme of ATP? Adenosine. Tripolyphosphate. That's ATP. Or triphosphate. We are very interested in is right here. Because they are high energy bonds. What are they? So the whole thing, what we call is ATP. How about goes here? AMP. Sorry, ADP. How about right here? AMP. And I said all the time, ATP become ADP, become AMP, that's okay. We don't want one thing happen. We don't want this guy happens. If CAMP generates with cyclase, chlorella will have water diarrhea. You lose water 2 hours 10 liter because the chlorella toxin activate cyclase. AMP becomes CAMP. The money is locked in your pockets. Your pocket is sealed. You cannot use it. You cannot be survived. So that's very interesting when we talk about these structures. I mean, you don't require to know, but when you ever do that, you see, that's a very boring chemical. You talk about all the time, adenine, 5 carbon ribose, and then the phosphate. That's all. And then the ATP is going through all these things. So we talk about ATP, there's 2 different levels, substrate level and the oxidative level. So we will talk about this after the spring break. We don't require to use sparing all the chemicals or something. You open book. But the one thing is important is how we calculate the ATP. How to do the calculation. How many ATP will generate through the whole aerobic respiration process. That will be the key point in the exam 3. So we better go through that and study that. Okay, so that's we will do after spring break. Okay. That's all we have today.